reactants. So next question, nitrogen monoxide O2 react to form nitrogen dioxide, room temperature, reaction can equilibrium. Okay. Delta H is negative, so it's exothermic reaction. Passed into a beaker. This is a beaker. Now, as you can see, this is a excellent question to understand what we were discussing in the last question. So in the last question, we were discussing about the closed system, open system, and the definitions, etc. Now, if you look closely, this is an open system. This is an open system. Why? Because if I represent system as like this is the system, and these are the surroundings. So this is how we show system. Basically, what we do is we put a boundary. I'll make this again. So this is a system, and the rest of the world is the surroundings. Now, if you look, this is a open system. Open system because matter can be exchanged with the surroundings, as well as energy can be exchanged from the surroundings. So it's an open system. So that is why we can't have an equilibrium state in this. So explain why a method does not allow the reaction to reach equilibrium, because energy exchange is okay, but you can't have matter exchange. And why you can't have a matter exchange? Again, due to Le-Chatelier principle, that say for example, because it's an open system, as oxygen gets used, more and more oxygen is available from the environment. So as more and more oxygen is available from the environment, the reaction will always keep moving in the forward direction. See, what Le-Chatelier is trying to say is that the equilibrium, in a state of equilibrium, if you increase the reactant, the concentration of the reactant, the equilibrium will shift in a direction which will try to decrease the concentration of the reactant. But here the concentration of reactant keeps on increasing. So how will it reach equilibrium? So I hope this is making sense. So the only way you can make this reach an equilibrium position is if you close this. So once you have put the NO and the O2 in the system, then you close the system. Then you close the lid. Now matter can't be exchanged, but the energy can be exchanged with the surroundings. So only then you will have a equilibrium state, a dynamic equilibrium state. Hope this is making sense. So in the previous question, I discussed this open system, matter as well as energy is exchanged. Closed system, matter is not exchanged, but energy can be exchanged. Isolated system, neither matter nor energy can be exchanged. So this is the example of an ideal thermos flask. There is something called an adiabatic system also, not in your syllabus, but I just mentioned it here. If anyone is interested, you can have a look at adiabatic system. On ChatGPT, you can have a look if you are interested. This is usually explained in detail in class level. So explain why we have done this. Apparatus is changed, equilibrium is reached. Okay. So temperature is then increased, position of equilibrium shift to the left. Okay, now let's try to understand. So now when the temperature is increased, the system wants to oppose the increase in temperature. How the system will try to oppose the increase in temperature is shifting towards a reaction which is endothermic. It will try to reduce the temperature. So if the equilibrium shifts to the left, that implies that on the left you have endothermic, and therefore you can deduce that the forward reaction will be an exothermic reaction. So explain why the position of equilibrium shifts to the left. It shifts to the left because the forward reaction is exothermic. Explain why the position of equilibrium shifts to the left. As we have discussed, basically, again and again, the core principle on which whole of this chapter hangs by is the Le-Chatelier principle. You should be very clear about Le-Chatelier principle. I have discussed this before in the previous questions also. So basically, when a change is made to the conditions of the system in a dynamic equilibrium, the system moves so as to oppose that change. we basically took an example of teenager and a parent. So whatever the parent will say, the teenager will try to oppose it. If the parent says play, the teenager will start studying. And if the parent says you have to study, the teenager will start playing. So a rough example to understand how Lee-Chatelier principle is put in action. So you should be very clear about Lee-Chatelier principle. Try to get as thorough as possible about this concept of Lee-Chatelier. And that is why the more and more questions you do, previous year question papers you do, the more you'll understand. The next question is pressure of the equilibrium system is an increased. Now, if you look at the reaction, you have 3 moles of reactants and 2 moles of products. So when you increase the pressure, it will move in a direction which will try to. So if you increase the pressure, the equilibrium basically wants to oppose this increase of pressure. It wants to decrease the pressure. However, it decreases the pressure by moving in the forward direction, by shifting the equilibrium to the right. Because from 3 moles you are coming to the condition, to the situation of 2 moles. So the reaction will move in the forward direction to oppose this increase. Okay, there's another small question I wanted to discuss. This involves, again, this is a very interesting question. This plays on oxidation numbers also. I hope you are thorough with oxidation number. If you are not, I'll put the link of one of my oxidation videos in the notes. You can have a look at that. So in this case, we are very sure that whenever chlorine is in the free state, the oxidation number would be 0. That is what I have written here. And whenever chlorine is in combined state, it is in combined state, XCl, XCl2, the oxidation will be -1. So for halogens, the oxidation number would be -1. So here if you see S2Cl2, here Cl has oxidation number of -1. Sulfur has an oxidation number of +1. I won't be going into the details of calculating the oxidation number. I'm assuming that you know oxidation number. Here it is 0. Here chlorine remains -1 and sulfur becomes +2. So in this case, sulfur is going from +1 to +2 in the forward direction. Forward chlorine, in the reverse direction, if you look closely, chlorine goes from -1 to 0. If you look closely, -1 to 0. So the question is, sulfur is oxidized in the forward direction? Yes, of course, because it goes from +1 to +2. This is what we discussed right now. Chlorine is oxidized in the reverse reaction. Yes, it is oxidized because it goes from -1 to